Joe Rogan has at long last uncovered the stunning picture that the Webb telescope caught. At long last appearance. What Oumuamua seems as though. In 2017, space experts spotted something surprising going through our planetary group. It was Oumuamua, the first known interstellar item to visit us. Yet, what do the pictures of Oumuamua uncover about its real essence? And could these pictures change all that we know about the universe? We should jump into the subtleties and figure out what this interstellar guest can enlighten us concerning the universe past our planetary group. Back in 2017, the Romy world got an enormous shock. The Dish Stars 1 telescope in Hawaii, which is consistently watching out for bizarre occasions occurring around the universe, spotted something thoroughly out of the standard. It was Oumuamua, the very first noticed interstellar item to pay our nearby planet group a visit. The revelation of Oumuamua was set off many inquiries among researchers and basically each and every individual who caught wind of it. Individuals were interested for clear reasons. Here was substantial confirmation that stuff from far past our nearby planet group could come meandering in. Presently, the James Webb Space Telescope has at last caught a stunning picture of this item that has uncovered its valid nature. Be that as it may, Oumuamua wasn't captivating because of where it came from. This article had a few pretty odd elements that set it aside from the standard comets and space rocks researchers were accustomed to seeing. For starters, its shape was something different. Most space rocks we experience are to some degree roundish or irregular, yet Oumuamua was long and thin. It was a stone loosening up to a football field, yet with a negligible part of the width. At that point, there's its way through space. Oumuamua flashed into our nearby planet group at a speed a point that made it clear it wasn't from around here. It was moving so quick that it was simply going through. It didn't become involved with circling the sun like most space trash that comes our direction. And maybe one of the most baffling things about Oumuamua was its absence of a committer story. Most comets have notable tails of gas and residue that stream out behind them. However, Oumuamua didn't have one of those. Notwithstanding getting pretty near the sun where you'd expect a comet to begin regurgitating material, Oumuamua didn't have a tail. This was a major sign that it wasn't your regular comet or space rock. Oumuamua's appearance resembled nothing we'd of all time seen before. Its interstellar beginning, uncommon shape, and surprising way of behaving had everybody from proficient cosmologists to relaxed space fans inquiring questions. What was Oumuamua truly? Where did it come from? And what might it at any point tell us about the universe past our sunlight-based framework? So, how did the James Webb Space Telescope spot the unusual article? The James Webb Space Telescope is a significant piece of innovation in space investigation. Named after James E. Webb, the spearheading NASA director who played an essential job in the Apollo missions, the telescope addresses the following jump forward in space observatories. Its venture from origination to the last wilderness is a story of coordinated effort, development, and the resolute human soul. The thought for the James Webb Space Telescope started coming to fruition in the late 1990s as a replacement to the Hubble Space Telescope, with the desire of looking further into the universe than at any point before. Created through an international cooperation drove by NASA, with critical commitments from the European Space Agency and the Canadian Space Agency, the telescope was planned to address central inquiries regarding the universe's earliest stars and universes, the arrangement of nearby planet groups, what's more, the potential for life somewhere else. At the core of the telescope's capacities is its setup of cutting-edge instruments and a gigantic 65M essential reflect made out of 18 hexagonal segments produced using gold-covered beryllium. This mirror is essentially bigger than Hubble's, permitting the telescope to gather more light and notice objects in far more noteworthy detail. The telescope's plan empowers it to see in the infrared range, which is fundamental for thinking back in time to see the principal universes that shaped after the enormous detonation, as their light has been extended into infrared frequencies by the extending universe. The telescope is furnished with 4 primary instruments, which are the near-infrared camera, the near-infrared spectrograph, the mid-infrared instrument, and the fine guidance sensor near-infrared imager and slitless spectrograph. Each instrument assumes a novel part, from capturing nitty-gritty pictures to investigating the substance piece of heavenly objects. One of the James Webb Space Telescope's most noteworthy highlights is its capacity to notice the air of exoplanets, possibly recognizing indications of livability or even life. By investigating the light from stars as it goes through an exoplanet's environment, The telescope can identify synthetic marks that might show the presence of water fume, carbon dioxide, methane, and other key particles. The telescope's way to the stars was not without its testes, including specialized obstacles, spending plan overwhelms, and delays. Anyway, following quite a while of fastidious arranging, development, and testing, the telescope was at last sent off on December 25, 2021, on board an Ariane 5 rocket from French Guiana. The telescope then set out on a month-long excursion to its operational circle at the second Lagrange point, around 1.15 million kilometers from Earth, where it stays protected from the sun's intensity and light, giving an unhindered perspective on the universe. Since its arrangement, it has started to satisfy its guarantee, bringing in stunning pictures and information that are reshaping our comprehension of the universe. Its initial accomplishments incorporate catching the most nitty-gritty perspectives yet of far-off systems, noticing the climates of exoplanets, and investigating thick infinite residue mists where new stars and planetary frameworks are being conceived. When AMU came onto the scene, the James Webb Space Telescope turned into our smartest option for drawing a nearer take a gander at it. Its setup of instruments and unmatched responsiveness to infrared light implied that it would be able to catch insights concerning AMU's shape, size, and potentially even its creation that different telescopes couldn't. The development to the telescope's perception of Oumuamua was a significant space occasion. Researchers and space devotees the same were on the edge of their seats, standing by to see what the telescope would uncover. The expectation was about the more extensive suggestions. This was our opportunity to acquire experiences that could apply to others like it, maybe even revealing insight into the building blocks of other planetary groups. It was a trial of our capacity to notice and grasp peculiarities from other star frameworks utilizing the most progressive instruments at our removal. For what reason does this article so much interest since Oumuamua zipped through our planetary group? It's been the star of many logical head-scratchers. One of the biggest discussions is its shape. At first, some thought it seemed to be a stogie, long and thin. However, then, another camp began contending that AMU could actually be more flapjack-like, level. And why? This goes to the heart of understanding AMU's excursion through space and what drives it. May have experienced en route. Jumping more profound, researchers have had a wide range of speculations about what lies under the surface for AMU and where it came from. One of the speculations is the nitrogen ice speculation. According to this, Oumuamua is a piece of nitrogen ice that severed from a Pluto-like world in a far-off star framework. If valid, this would make sense of its strange speed increase as it passed by the Sun and enlighten us regarding bit about the area it came from. One of the most talked about speculations is the possibility that Oumuamua could be a counterfeit item, maybe a test aroma by a high-level outsider human progress. This hypothesis is fueled by its strange speed increase as it passed through our planetary group, which some researchers contend could be indicative of a light sail, a thin, wide surface impelled by sun-based radiation. While this hypothesis inclines more towards science fiction and needs substantial proof, it shows the tremendous effect AMU has had on our creative mind and our craving to find associations with other smart life in the universe. Another compelling hypothesis suggests that Oumuamua may be a piece from an upset planet or a planetary structure block known as a planetesimal from another star framework. This hypothesis says that Oumuamua could be a piece of a larger divine body that was destroyed by gravitational forces, perhaps during a close experience with a star or a giant planet. Such an event could make sense of its prolonged shape and strange direction, as well as give insights into the violent cycles that can happen in youthful planetary groups. The real essence of Oumuamua may remain elusive. Every hypothesis adds to a broader comprehension of the cycles at play in our universe. However, with something as strange as Oumuamua, it's easy to allow our minds to roam free. Sure, AMU is unusual, yet bouncing straight to extraterrestrial explanations without solid proof isn't how science works. So as we piece together the riddle that is Oumuamua, keeping an open is crucial mind, yet additionally stay grounded. The reality about this interstellar guest is liable to be weird enough without expecting to venture into the universe of sci-fi. So what did the new picture caught by the telescope uncover that has had the science world so energized? When the James Webb Space Telescope turned its look toward Oumuamua, the expectation was tangible. It was whenever we first were getting a genuine, very close gander at an interstellar object that had meandered into our solar system. The picture we got was pivotal. Interestingly, we saw AMU as a particular object with highlights and qualities. The degree of detail was not normal for whatever we might have accomplished with past telescope views. This was our most memorable genuine look at something from another star framework, and it was essentially as exciting as it sounds. This picture and the information that accompanied it had the possibility to either back up or obliterate a great deal of the speculations that had been going around about Oumuamua. Was it the stoga-formed rock some had envisioned, or was it more pancake-like, as others had conjectured? The underlying understandings of the picture began to offer us some response. Researchers started talking about the subtleties, contrasting them with the different models and expectations that had been made. For some, the picture was an affirmation. For others, it had returned to the drawing board. What was clear was that AMU was proceeding to shock us. Its shape, which showed up more complicated than many had expected, tested our presumptions about what interstellar articles could seem to be. And with respect to its composition, the information recommended that Oumuamua could, for sure, be something very surprising, not simply a straightforward stone or ice ball. This disclosure denoted the start of another time in our investigation of interstellar items. With this level of detail and lucidity, we could begin to sort out more exact accounts of these drifters. AMU's visit and the information we've accumulated from it could help us comprehend and give experiences into the cycles at work in other star frameworks. The telescope's first picture of Oumuamua was a key that began opening responses to a portion of our inquiries regarding the universe. And as we keep on concentrating on this picture and assemble more information, we're probably going to view that as Oumuamua has significantly more mysteries to uncover. So how about we separate what this all method for how we might interpret interstellar objects and their position in the grand plan of things. Getting a clear shot of AMU with a telescope is nothing to joke about because it's our most memorable genuine take a gander at something from outside our solar system. This has allowed us a unique opportunity to concentrate on material from one more piece of the world. This is key because each little detail we find out about AMU can enlighten us something concerning where it came from and how it wound up here. Yet, the implications go far past only one object. By concentrating on Oumuamua, we get signs about the cycles at work in other star systems. For instance, if AMU truly is a lump of nitrogen ice, as a few speculations suggest, it could really mean that there are Pluto-like planets or articles in other star systems going through similar cycles as in our own solar system. And here's something else. AMU's visit suggests that interstellar objects may be going through our solar system more frequently than we originally suspected. This has immense ramifications for our thought process about our place in the universe. Each of these interstellar visitors has the potential to show us a novel, new thing about the universe. Accordingly, the telescope's perceptions of AMU are helping us draw an obvious conclusion regarding our solar system and the more extensive universe. We're beginning to perceive how the development of interstellar objects like AMU could be an ongoing idea connecting different star systems together. So as we proceed to concentrate on Oumuamua and anticipate the following space guest, we're equipped with better instruments and a developing knowledge base. Yet, what could the proceeded with investigation of objects like Oumuamua uncover? First of all, we may uncover more about the structure blocks of planet development and the common or rare materials in different pieces of the system. We could find out about the forces and occasions that send these articles on their interstellar journeys, from gravitational pushes to gigantic crashes. The greatest inquiry this object has made is about existence past Earth. While interstellar objects like Oumuamua probably won't hold on to outsider life, the materials they convey and the conditions they've experienced could give vital setting to understanding where and how life could exist in the universe. As we look to the future, the possibilities for interstellar research are vast. With each new disclosure, we grow our comprehension of the world and our place inside it. Surely let's proceed. Additionally, the investigation of interstellar objects like Oumuamua could likewise reveal insight into the elements of planetary frameworks and other star systems. By examining their directions and trademark, researchers can gather experiences into how planets structure, move, and collaborate inside their separate frameworks. This data could help refine existing models of planetary development and advancement, growing our comprehension of the variety and intricacy of planetary frameworks across the universe. Also, the investigation of interstellar items presents a one-of-a-kind chance to study the interstellar medium itself, the vast area of space between stars. As these objects travel through space, they collaborate with this medium, possibly conveying hints of its creation and properties. By dissecting the structure of interstellar objects like Oumuamua, researchers can acquire important bits of knowledge into the compound cosmetics and physical states of the interstellar medium, propelling our insight into the astronomical climate encompassing our nearby planet group. Besides, proceeded with investigation of interstellar items could illuminate our comprehension of the more extensive cycles molding galaxies and the universe as a whole. By following the origins and directions of these objects, researchers can sort out the multifaceted dance of stars, systems, and dim matter that administers the construction and advancement of the universe. This enormous viewpoint offers tempting open doors to investigate essential inquiries concerning the nature of spacetime and the universe's ultimate fate. In Rundown, the new picture caught by the James Webb Space Telescope of Oumuamua addresses a critical achievement in our investigation of interstellar objects. As we dive more profound into the mysteries of objects like Oumuamua, we stand to acquire significant experiences into planetary arrangement, the interstellar medium, and the more extensive elements of the universe. With each new disclosure, we draw nearer to unwinding the privileged insights of the universe and our place inside it.